This video is on cyclohexanes and the chair and boat conformation. So the most basic 6-membered ring, cyclohexane, can exist in 2 different conformations, a chair and a boat. The chair looks something like this. You need to become very good at drawing these because you will be asked to draw them a lot. So you can take 2 approaches, whether you draw a slanted V first, followed by parallel lines, and then cap it off with an upside down of the initial V, or you start with 2 parallel lines and then cap each end off with a V. Or maybe you have another way, whatever, you do you, but as long as you're able to draw these, you'll be golden. Now that we have this somewhat 3D model of the cyclohexane, we will notice that there are 2 different types of hydrogen around it. We have the axial hydrogens, which alternate up and down around the ring, and equatorial hydrogens, which are around the equator of the ring, i.e. somewhat horizontal. We can see that from a Newman projection, all of the hydrogens are staggered. You need to be able to identify the axial hydrogens and equatorial hydrogens on any chair conformation. Matter of fact, you need to be able to draw them appropriately. So a key tip here is that all equatorial hydrogens are parallel to carbon-carbon bonds in the chair structure itself, like here and here, whilst the axial ones are up-down in a vertical fashion. The boat conformation is less stable than the chair conformation. If we look at this 3D structure, we'll notice that the hydrogens pointing inwards, referred to as the flagpole hydrogens, are invading each other's space, causing steric strain. Furthermore, if we take a Newman projection along one of these 2 sets of carbons, we'll notice that the hydrogens are eclipsed on 4 out of the 6 carbons. This means that when you have a 6-membered ring, such as cyclohexane, it's more likely to exist as a chair structure instead of a boat structure. There's also this thing called a ring flip, where a chair can flip around so that all of its axial positions become equatorial positions. And this occurs through the boat conformation. This also brings us to the organic chemist joke of, why did the organic chemist drown? Because his boat turned into a chair. Ha 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 ha. Okay, we're done. But for real, you need to be able to draw a ring flip. So if we look at this chair structure and we number the carbons as such, for a ring flip to occur, first the 4th carbon needs to shift upwards. This causes a rearrangement of orientations to get the boat conformation. Once we have the boat conformation, the number 1 carbon flips downwards to yield us the flipped ring structure.